For a 200 amp service in a commercial building, the National Electrical Code, or NEC, dictates the appropriate conductor size to ensure safety and prevent overheating. The initial step is to determine the ampacity requirements. A 200 amp service inherently requires conductors capable of handling at least 200 amps. However, the NEC mandates that conductors not be loaded to more than 80% of their ampacity when dealing with continuous loads. This derating factor is crucial for preventing thermal overload. Now let's consider 2/0 THHN copper wire. It has a listed ampacity of 195 amps as per NEC table 310.15b16. Applying the 80% derating factor, we multiply 195 amps by 0.8, which yields 156 amps. This means that 2/0 THHN copper, when derated, can only safely carry 156 amps for continuous loads. Since the service is rated for 200 amps, 2/0 THHN copper is inadequate because it does not meet the minimum ampacity requirement after derating. Moving on to 3/0 THHN copper wire, it boasts a higher ampacity rating compared to 2/0 THHN copper. Consulting NEC table 310.15b16, we find that 3/0 THHN copper has an ampacity of 225 amps. Applying the same 80% derating factor, we multiply 225 amps by 0.8, resulting in 180 amps. However, this calculation is incorrect. You do not apply the 80% derating factor to the wire itself. The 80% derating factor is applied to the load. For example, if you had a 200 amp load that was continuous, then the breaker feeding that load would have to be 250 amps, meaning 200 amps/0.8 equals 250 amps. Therefore, with a 200 amp service, you must use wire that is rated for 200 amps. So 3/0 THHN copper wire is appropriate, as it is rated to 225 amps and therefore it is greater than 200 amps. There are also other factors that could affect wire sizing, such as ambient temperature correction factors. If the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, a temperature correction factor must be applied to the ampacity of the conductor as per NEC table 310.15b2. These correction factors are typically less than 1 have reduced the allowable ampacity of the conductor. Similarly, if multiple current-carrying conductors are bundled together in a raceway or cable, a derating factor must be applied as per NEC table 310.15b3. These adjustment factors account for the increased heat generated by multiple conductors in close proximity. For example, if there are 4 to 6 current-carrying conductors in a raceway, the ampacity of each conductor must be reduced to 80% of its original value. If there are 7 to 9 current-carrying conductors, the ampacity must be reduced to 70%. In addition to ampacity, voltage drop must also be considered when selecting conductor size. Voltage drop refers to the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, the following formula can be used. Voltage drop equals 2 times the length of the conductor in feet, multiplied by the current in amps, multiplied by the impedance of the conductor in ohms per foot, divided by 1000. The impedance of the conductor can be obtained from NEC Chapter 9, Table 9. Once the voltage drop is calculated, it can be compared to the allowable voltage drop to determine if the conductor size is adequate. If the voltage drop exceeds the allowable limit, a larger conductor size must be selected. In summary, selecting the appropriate conductor size for a 200 amp service involves several considerations. Firstly, determining the ampacity requirements of the service. Secondly, selecting a conductor with an ampacity rating that meets or exceeds the service ampacity after applying any applicable derating factors. Thirdly, considering ambient temperature correction factors and adjustment factors for multiple conductors in a raceway. Fourthly, calculating voltage drop to ensure it remains within acceptable limits. Lastly, consulting the NEC and local electrical codes to ensure compliance with all applicable requirements. By carefully considering these factors, you can select the appropriate conductor size for a 200 amp service and ensure the safe and reliable operation of the electrical system. It's essential to emphasize the importance of adhering to the NEC guidelines and consulting with a qualified electrician. These professionals possess the expertise to assess specific project requirements, conduct accurate calculations, and ensure installations comply with all safety regulations. Incorrect wire sizing can lead to serious consequences, including overheating, electrical fires, and equipment damage. Therefore, relying on qualified expertise is crucial for safe and effective electrical system design and installation. Different types of loads connected to the 200 amp service may have different characteristics that affect conductor sizing. For example, motor loads typically require larger conductors than lighting loads due to the high inrush current they draw when starting. Inrush current can be several times the normal operating current of the motor, so the conductors must be sized to handle this surge without excessive voltage drop. Continuous loads, which are defined as loads that operate for 3 hours or more at a time, also require special consideration. As mentioned earlier, the NEC requires that conductors supplying continuous loads be derated to 80% of their ampacity. This is to prevent overheating of the conductors due to prolonged operation at high current levels. The type of insulation used on the conductor can also affect its ampacity rating. THHN insulation is a common type of insulation used for building wiring. It is rated for a maximum operating temperature of 90 degrees Celsius or 194 degrees Fahrenheit in dry locations and 75 degrees Celsius or 167 degrees Fahrenheit in wet locations. Other types of insulation, such as XHHW, may have different temperature ratings and ampacity values. The ampacity of a conductor decreases as its temperature increases. Therefore, it is important to select a conductor with an insulation rating that is appropriate for the ambient temperature and operating conditions. The length of the conductor run also affects voltage drop. As the length of the conductor increases, the voltage drop also increases. This is because the resistance of the conductor is proportional to its length. For long conductor runs, it may be necessary to increase the conductor size to reduce voltage drop and ensure that equipment operates properly. The location of the service entrance can also affect conductor sizing. If the service entrance is located in a hot or humid environment, it may be necessary to derate the conductors to account for the increased ambient temperature. Additionally, if the service entrance is located in a corrosive environment, it may be necessary to use conductors with special corrosion-resistant insulation. The presence of harmonics in the electrical system can also affect conductor sizing. Harmonics are non-sinusoidal waveforms that can cause increased current flow in the neutral conductor. If the harmonic content is high, it may be necessary to increase the size of the neutral conductor to prevent overheating. In addition to the NEC, local electrical codes may also have requirements for conductor sizing. It is important to consult with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. The National Electrical Code is updated every 3 years, so it is important to use the latest edition when designing and installing electrical systems. The NEC is a comprehensive set of standards that covers all aspects of electrical safety, including conductor sizing, overcurrent protection, grounding, and wiring methods. Compliance with the NEC is essential for ensuring the safe and reliable operation of electrical systems. The use of aluminum conductors is also an option for 200 amp services. Aluminum conductors are less expensive than copper conductors, but they have a lower ampacity rating. For example, 3/0 aluminum THHN wire has an ampacity of only 200 amps. Therefore, a larger size aluminum conductor may be required to achieve the same ampacity as a copper conductor. Aluminum conductors also have a higher coefficient of thermal expansion than copper conductors. This means that aluminum conductors expand and contract more than copper conductors when subjected to temperature changes. This can cause problems with connections if the conductors are not properly installed and maintained. When using aluminum conductors, it is important to use connectors that are specifically designed for use with aluminum. These connectors are typically made of aluminum and have a special coating to prevent corrosion. It is also important to use an antioxidant compound when making connections to aluminum conductors. This compound helps to prevent oxidation of the aluminum, which can lead to increased resistance and overheating. The type of raceway used to enclose the conductors can also affect their ampacity rating. Some types of raceways, such as PVC conduit, have a lower thermal conductivity than others, such as metal conduit. This means that conductors installed in PVC conduit may have a lower ampacity rating than conductors installed in metal conduit. The NEC provides tables that list the ampacity of conductors in different types of raceways. It is important to consult these tables when selecting the appropriate conductor size for a particular installation. The use of energy-efficient lighting and equipment can reduce the overall load on the electrical system. This can allow for the use of smaller conductors and overcurrent protection devices. Energy-efficient lighting and equipment also reduce energy consumption and save money on electricity bills. The installation of a surge protective device can protect sensitive electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. A surge protective device diverts the surge current to ground, protecting the equipment from damage. Regular maintenance of the electrical system is essential for ensuring its safe and reliable operation. This includes inspecting and testing the wiring, connections, and overcurrent protection devices. Any damaged or worn component should be replaced promptly. A qualified electrician should perform electrical maintenance. In conclusion, selecting the appropriate conductor size for a 200 amp service is a complex process that requires careful consideration of many factors. The NEC provides detailed guidelines for conductor sizing, but it is important to consult with a qualified electrician to ensure that the installation complies with all applicable codes and regulations. Remember to calculate the load correctly, select the appropriate wire size, consider the ambient temperature, apply derating factors when necessary, account for voltage drop, use the correct type of connectors, and perform regular maintenance. By following these guidelines, you can ensure the safe and reliable operation of your electrical system. Always prioritize safety and consult with qualified professionals when working with electricity. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent injury or damage. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before making any changes to your electrical system.